In my last video, I discussed resultant of forces or vectors. Now we want to discuss the resolution of forces, because sometimes we have a single vector known as a resultant which has the same magnitude and direction as two or more other forces acting together. That is the resultant. Sometimes you can have the resultant and it warrants that you have to resolve the resultant into the different component vectors that can come together to form that single vector known as resultant. Once you do so, you have now resolved the vectors into its various components, and that is what we are here to discuss. Now, for example, now let's say this is the Cartesian plane where you have the y-axis and this is the x-axis. Okay, now supposing there is a force here, and that force is inclined at an angle theta. You can see that this is our x component and this is our y component, or here can still be the y component. Okay, now, and this is, let's say, the force we are talking about is force P. If I want to consider x, I will talk about adjacent over hypotenuse, because here is adjacent. The side facing my angle is opposite, while here is adjacent, and here is hypotenuse. Okay, now if I take cos theta, for instance, will give me x over p, because it is adjacent over hypotenuse, which means x will give me p cos theta. Okay, so let's say the force here is px, while the force here is py, for instance, py, which means my px will turn into p cos theta for the horizontal component, because this is horizontal component. The x-axis is under the horizontal component. Now, if I want to get the value of py, it is opposite hypotenuse, which is sine. Hence, sine theta will now be py all over p plus multiply py will give me p sine theta. So this is the vertical component of the vector. Okay, so which means whenever you are looking for the vertical component of a vector inclined to the horizontal, the formula you use is py is p sine theta. Y for the horizontal is p cos theta. You know that when this is inclined to the vertical, it's a different thing altogether. So take note, because if this angle is moved from here to here, the reverse becomes the case. This will be bearing sine, while this will be bearing cosine. Also, the directions or the quadrant where it falls in can even determine its value, because assuming this force P is here, you can see that the x component will now be negative, because this is a negative axis. So take note of all these things. If it appeared here, you can see that the y component and the x component will both be negative. If it appears here, you can see that only y component will be negative, while x is still positive. So the appearance where it falls into is still also important. We normally take the angle inclined to the horizontal. If it is inclined to the vertical, you can subtract the angle from 90 degrees to get the angle at the horizontal. Or if it is here, the reverse becomes the case, because x, which is now here, opposite sides angle, here is now your x, becomes the opposite hypotenuse over hypotenuse. So this turns to sine, while the y turns to cosine. So let us take this question here to understand actually what I'm talking about. A force P is 230 Newton. It is inclined to the horizontal at an angle of 25 degrees. Find the horizontal and vertical components. So let's say this is the vectors we are talking about. These are the vectors we're talking about. And this is the resultant. And the resultant force, which is 230 Newton, inclined to the horizontal at an angle of 25 degrees. So this is my y. This is py. I don't know why this is px. Remember, py is equal to p sine theta, while px is equal to p cos theta, from what I've just given you previously. So to get my Py now, Py will now be P. Our P is 230 times sine theta, which is sine 25 degrees. So Py will give me 230 multiplying sine 25. So let's get the value of sine 25 degrees. Sine 25 degrees will give me 0.4226. So Py will now be 230 times 0.4226. This is now 97.2 approximately Newton. This is the value of Py. So let's get Px. Px is P cos theta. P cos theta. So my Px will now be P, which is 230 Newton times cos 25 degrees. So Px will now be 230 times cos 25. This is now 0.9063. So Px will now be 230 times 0.9063. This will give me 208.4 Newton. Okay, so if you've enjoyed what you've watched, kindly consider subscribing to my channel. It will give you notification whenever a new video is uploaded. Thank you.